Notes on solving one-step equations. You'll find that on page 113 in your book. Start by putting the goal at the top. Use inverse operations to solve one-step equations and create a column for questions and a section for a conclusion at the bottom. Now I'm going to show you how to solve equations in a way that's different than in the book. It's called backtracking. We'll use both the book method and backtracking, but at first we're just going to backtrack. So just write backtracking in your notes and we'll draw a picture of what it looks like. We've been talking about a mystery number. We're going to use a box to represent that mystery number. And then something happens to the mystery number, and so we'll use an arrow. And then the mystery number becomes a new number that we're usually given a clue about. So we call this backtracking. So we'll start with example 1a on page 115. There's a mystery number. We don't know what it is. It's x. Something happened to it. See if you can look on page 115 and see if you can figure out what happened to that mystery number. What happened was 13 was added to it. So there was a number, so we make a box. When something happens to it, we make an arrow, and we write what happens, like a picture. So 13 was added to it. It became 41. So we put 41 in the box since we know what the value is. It becomes an equation. Then we backtrack and do the opposite of add 13, which is to subtract 13. So over on the side we can do our computation. 41 minus 13 is 28. So the mystery number is 28. So we write x is equal to 28. A second mystery number. When we write a number next to a variable, that means multiplication. So there was a number. We don't know what it is. It was multiplied by 6. So we put an arrow connected to a new box and we write that it was multiplied by 6. That's our clue. It turns into an equation when we know what the value is. It became 27. So we fill that in the second box. Now we work backwards and divide by 6. So 27 divided by 6 turns out to be 4.5. So sometimes our mystery numbers might be fractions or decimals, and that's okay. If you want to hit pause right here on the video, I didn't do C, but you can take a look and see what that looks like. I'm going to do one that looks like that a little bit later in the video. But I skipped down to example 2. Okay, for example 2, I'm going to stop the video here in just a second and read the problem. So example 2. It says the meteorologist on Channel 3 announced that a record high temperature had been set in Kirkland today. The new record is 2.8 degrees Fahrenheit more than the old record. Today's high temperature was 98.3 degrees. What was the old record? Write a one-step equation and solve it. So the first thing we need to do is declare a variable. So we're going to say let n equal the record high temperature. And that's what I wrote, but that's actually a mistake, and we'll fix it here in a second. So that's not the mystery number. We know what the record high temperature was. It was 98.3. So we only use a variable when we don't know what the number is. I'm going to hit stop here. See if you can read the problem and figure out what the real mystery number is, not the today's record high temperature. See if you can fix my mistake before I fix it. Okay, I'm going to continue. And I believe the pause there is me figuring out what my mistake is as I'm reading the problem. So I put a line through it. It's not today's record high temperature. the unknown number is the old record high temperature. And now we can write an equation. The old record high temperature, N, plus 2.8 is going to give us the new record of 98.3. So that's an equation to figure out what the old one was. So now we have a mystery number. So we're going to use backtracking. There was a number. 2.8 was added to it. It became 98.3. So we do the opposite to backtrack, which is subtract 2.8. So 98.3 subtract 2.8, and we get 95.5. So the old record was 95.5. Okay, we're going to do a couple more examples. We'll call them example 3A and example 3B. Sometimes the symbols make it a little hard to figure out what happened to the mystery number. So I'm going to do a couple that are like that. So we're going to write 20 equals some number divided by 6. So there was a number. It was, see if you can guess what I'm going to write here, because it's not at all obvious. We can't just go left to right. We have to look and see what happened to the mystery number. In this case, it's W. See if you can see what happened to it. It was divided by -6. And it became 20. The opposite of dividing by 6 is multiplying by 6. So 20 times -6 is -120, so W is equal to -120. That's going to be one of the more challenging types of equations to solve. Okay, last one. There was a number. It was multiplied by 9, so we write an arrow, and underneath that we put multiplied by 9. And it became 72. The opposite of multiplying by 9 is dividing by 9, so we do 72 divided by 9. (72) divided by 9 is 8, so K was equal to 8.